Session. Walid, stage is
Thanks
yours.
a lot. So great to be here again. My name is Walid Negam, and I just want to be a little bit provocative today. I changed the title and presentation a software eclipse because I think that's it's going to be a metaphor for defending growth, especially in the sectors that I'm going to be covering today, which is industrial sectors, automotive, aerospace, and others. But real first, what's an eclipse? Eclipse is when one celestial body is overshadowed by another, and it's sort of a change in perception, right? You're in darkness, for example. And it serves as a metaphor for today's presentation because we know that software is dominating, right? Software dominates a lot of the value creation today. And if you look at the valuations of startups and big companies alike, it resides in software, right? In the fact that their software plays. In fact, over the last 8 months or so, the number of billion-dollar companies, unicorns, went from 400 to about 700. So significant value creation in software. However, in the coming decades, we'll also see trillions of dollars invested in these new catalysts of economic growth that go a little bit beyond software, right? If you think about energy and energy transition, you talk about hydrogen fuel cells, aviation. If you look at even space, right? There's about 155 launch vehicles just up and running today to bring up these constellations, right? These low Earth orbit constellations. And then finally, in the automotive industry, I mean, we don't buy cars, right? We buy the in-car experience. So I think the idea that software is being eclipsed by hardware is kind of the theme of the presentation today. And what are the implications for product developers when that starts to happen? Maybe it's not an eclipse of software, but maybe a partial eclipse. So get started here. There's 3 videos going to play, and I just wanted to give you an idea of what we mean by the penetration of software is more than we think in the physical world, right? So each of these videos are meant to show that software does run the show, right? So if you're a software developer, the hardware seems to be behind the scenes, but make no mistake, there is hardware here. In the first video, it's by General Motors Cruise brand, right? And it's steering, accelerating, and navigating on its own. It's stopping at the right time. 95 or 90% of all of the innovations in automotive will be software. It's not going to be mechanics anymore. In the second video, you can see the design team at Airbus showing off what's basically an entirely new urban air mobility solution, right? This is a particular aircraft that takes off vertically and lands. It needs energy, it needs batteries, and software is managing the batteries. Software is managing the autonomous flight when it goes vertical and landing. And in the last video, you'll see a swarm of robots. If you probably saw it whiz by in an automated warehouse. And these robots are moving at 4 meters per second and with a clearance of about 5 millimeters. That's all, the magic is in software, right? So it's obvious that software is crucial to these solutions. And just to get a little bit deeper in and trying to transition between software and hardware, as you could see here, the automobile is moving from metal to code. And if you look a little bit closer at the automotive industry, they're speaking about themselves as software players, right? So the innovation inertia in hardware is being replaced by software velocity and how you can make this vehicle programmable. Instead of having a hardware chassis, you have a software chassis, right? And you're loading up over-the-air functionality. What is that? Lane departure warnings, collision avoidance signals, driver monitoring. It's just basically you're buying the software in the vehicle. And if you're a software developer watching this, you're very familiar with the image on the right? This is a cloud-native architecture. And OEMs are not going to be looking at a monolithic picture on the left. They're going to be looking at microservices, software delivered on the fly, and they're actually hiring software engineers at scale, right? GM, I think, is hiring 5,000 software and digital designers. VW made a similar move. But here's where I think the catch starts to happen is that there's critical safety requirements in automotive. There are real-time performance challenges in automotive, and there's silicon in automotive, right? So silicon is definitely a big part of complex products. Beyond automotive, though, software is a defining cost in every end solution. This is just a little bit perspective on what the R&D spend. I'll share a little bit of of where this number comes into play in terms of Capgemini engineering. But if you look at all the big spenders, if you add them all up, and the little spenders, it's about $1.9 trillion on research and development and engineering. And most of that spend is going to be moving into the blue bar, right? The blue bar meaning digital capability, data science, the connectivity and software and embedded software. So the shift is clearly in software. Okay, now I've said software dominates. Here's the however, right? The however is that we are in the physical world, right? And if the provocation is that software is going to be eclipsed, the provocation is that it's going to be eclipsed by hardware. And I think that's an exaggeration. There's going to be a role for hardware to play in this physical world, and that's where a lot of these opportunities are going to be, right? In automotive, in life sciences, in aerospace. And if you think of the things that are out there, the chart at the top right is by a company called ARM. Anything that has a battery, anything that runs on electricity probably has an ARM-based chipset inside it. And there's 190 billion of these things running around. Anything from sensors in your smart home to factories and facilities in the automotive sector, a significant number of electronic control units. Just last week, if you're watching Amazon's product launch, I think it's undeniable that they're getting into the physical domain as well. They had a surveillance robot, something for the kids. But there's semiconductors and electronics in these products. And the question is, what are the implications for product developers when you have to deal with this hardware, right? There's going to be a software component, but in order to capture this fresh opportunity, right, in the industrial sector, in aerospace, in life sciences, the software developer, the product developer has to cross over. They have to cross over into the hardware world, and then vice versa. The hardware folks have to cross over into the software. I didn't talk about Capgemini. I just wanted to touch a little bit about Capgemini. We're a recognizable name in the IT services space, about approaching $20 billion in revenue, operating globally. Of course, one of our areas of focus is engineering. We have about 52,000 engineers. What does that mean? We have 12,000 people that just dedicated to aerospace. You can look up our certificate with EASA, which is the European Space Agency. We're responsible for design and development in the aviation sector. And we have a similar large number of folks in automotive and also in life sciences. So when it comes to building complex physical products, Capgemini Engineering has a pretty good track record, pretty good resume. So this talent squeeze, again, as business leaders or as technology leaders, it's important to recognize that there is a talent squeeze happening when you think about complex products. I mean, it's easy to say everything, like when Facebook went down, everybody went nuts, right? Facebook's down, I can't reach anybody because I don't have Facebook. But what happens when you put some code in an automobile, in a car, and you just haven't done it right? You get into a collision, the sensor is miscalibrated. I think these are the types of things that a software developer and a product is going to have to get more versed in. And there has to be a little bit of a different approach than just pure agile, right? So pure agile says it's about continuous delivery, it's about code, velocity, but when you have a hardware product that's a little bit more complex, you have to take into consideration safety criticality, real-time performance. So that the language barrier between the software world and the hardware has to be bridged. And that diagram in the middle just gives you an idea of the big difference. There's a literal V model when you think of a complex product. You have to sort out all the requirements first, and then you have to certify the product in front of regulators, right? You can't just release a plane you can't just fly a plane overnight. In the software world, I mean, if you look at Spotify, 6 builds a day, I think is what it takes. Yeah, it has about 6 production deployments a week. You can't do that in the automotive realm. So both of those worlds have to somehow come together. And this sort of builds into the implications. If you're a product developer, if you run a product development team, if you want to take advantage of some of these incredible opportunities, I think the implications are 3 at least, right? First, software engineers have to carefully architect alongside hardware teams, right? If you want to capitalize on clean energy, if you want to capitalize on automotive sector transition to the software-defined car, there has to be the monetization path is through trustworthy software-defined systems, right? So it's a very different paradigm. I think second, that V model of hard requirements, then certification in front of regulators has to be loosened up a little bit without sacrificing safety criticality. And you can do that in virtual environments, right? So beyond the physical. And finally, product developers, the planet matters. Product development teams have to consider reducing waste, energy efficiency. You have to go beyond the product and beyond the end of life of the product.